Good morning, everyone. I hope all are doing well today. So let me start with a short story you all might have here. Newton and the falling apple. Yeah, apple. One day, Newton was sitting under an apple tree. Suddenly, an apple fell. Newton wondered, why did it fall straight down? Okay, fall straight down and not sideways like this. Okay, not sideways or upward like this. So this curiosity led him to discover gravity and motion principles. Okay, so it's all start with that one apple. So let me ask you all, what makes object speed up or slow down? You can unmute your mic or you can message me in the chat box. So, what my question is, what makes object speed up or down? What is the reason behind that? Is there any principle behind that? You can unmute yourself and tell the answer. What do you think about that question? What makes objects speed up or slow down? Any answer? Okay, good. So that's what we are going to explore today. How objects move when they are accelerated. So you are familiar with that term, accelerated. Yes. So how objects move when they are accelerated. And we can predict their motion using some beautiful equations that's called as kinematic equation. Okay, so now we are just to recall our previous class. Okay, so let's quickly test your basics with that velocity, acceleration, and distance, displacement with some questions. Okay, wait, I will share the screen and you can tell that answer. Yes. Okay. So what is acceleration? Option. There are four options there. A, change in position. B, change in velocity over time. C, constant speed. And finally, total distance. What is acceleration? Answer, please. What is acceleration? Change in position or constant speed or total distance, change in velocity over time. What is acceleration? If you know the answer, please unmute yourself and you can tell that answer. It may be correct or wrong. It doesn't matter. Okay. What is acceleration? Already you are familiar with that acceleration from your 8th, 7th class. Okay. Acceleration means velocity changes over time. That means change in velocity over time. Yes, is it correct? So we can choose this option. It may be wrong or it may be correct. Okay. Yes, correct. Change in velocity over time. We can move into the next question. Which of these is a vector quantity? Already you are familiar with that. There are two type of quantity. That is a vector quantity and another one is scalar quantity. And you know very well about that. What do you mean by vector quantity and what do you mean by scalar quantity? Yeah. Scalar means only, it has only value, magnitude. Vector means that quantity has both magnitude and direction. So underline that word, directions. So speed is a vector quantity or not? Distance, it is a vector quantity or not? Displacement and time. So what do you think about this four option? Which one is a vector quantity? Speed, it has direction. Distance, do you think distance has a direction or displacement or time? So time, there is no possibility in terms of directions. Okay, let me go into that answer. So here speed is a scalar quantity because speed has that one object has only speed. That means it has only value, not the direction, and as well as distance also. So distance is a scalar quantity, speed is a scalar quantity. Yeah, time is also scalar quantity because you have only value in terms of time. Yeah, there are no direction related to the time. Okay, so then displacement is a vector quantity. Is it correct? Okay, we can move into the next one. So that is a very simple problem. A car's speed increases from 5 meter per second to 15 meter per second in 5 seconds. Okay. 5 years means 5 seconds. 1, 2, 3, 4, 5. Okay. So car speed increases from 5. What is its acceleration? Already you know that acceleration means change in velocity by time, sir. Yeah. Change in velocity means there are two velocities there. Yes. One is initial velocity. Another one, what is? Another one, final velocity. Is it correct? So here 5 meter per second is the initial velocity because the car speed increases from. So the from denotes the initial. 2, 15 meter per second denotes the final. So initial speed 5, final speed 15 in 5 seconds. What is its acceleration? If you know the answer, please unmute yourself and tell me, or you can message me in the chat box. Acceleration is the change in velocity by time. Change in velocity means final velocity minus initial velocity. Final velocity 15, initial velocity 5. So 15 minus 5, 15 minus 5, 10. Yeah, okay. So 10 by time. So here time 5 seconds. So 10 by 5, which gives, which gives, yes, 2. Is it correct? 2. So what is its acceleration? 2 meter per second square. Is it correct? We can choose this option B. Okay. Yes, correct. So this is a just a recall of our previous class. Okay, right. Oh, very good. 2 meter per second and unit 2 meter per second square. Yes, correct. Very good. Okay, let's recall what are the types of motion. types of motion. One is uniform motion. Another one is accelerated motion. One is uniform motion and another one is accelerated motion. Uniform means constant. Yeah. So constant speed. Constant speed. And accelerated motion means speed or direction changes. So uniform motion means constant speed. Accelerated motion means it it vary in the direction or in the value of speed. Okay, ma'am, please proceed, ma'am. Please. Proceed, madam. Proceed, madam.
Yes, am I audible?
Yes, madam. Yes.
ఓకే. సో ఇప్పుడు అందరికీ అర్థమైందా ఏం చెప్తున్నారు సార్ అని? ఇప్పుడు సపోజ్ మనము విజయవాడ నుంచి ఒంగోలుకి వెళ్తున్నాము అనుకోండి. ఎక్కడి నుంచి ఎక్కడ? విజయవాడ నుంచి ఒంగోలు వెళ్తున్నామని అనుకోండి. లేకపోతే విజయవాడ నుంచి నెల్లూరుకి వెళ్తున్నాము. అలా వెళ్తున్నప్పుడు ఏమవుతుంది? ఖచ్చితంగా ట్రాఫిక్ ఉంటుంది, సిగ్నల్ ఉంటుంది, అవునా కదా? వేరేమేమి ఉంటుంది? రోడ్డు బాగుండదు. సమ్ టైమ్స్ హైవే అంటే బాగుంటుంది రోడ్డు, లేకపోతే బాగుండదు. అప్పుడు ఏం చేస్తాము? సేమ్ స్పీడ్ లో వెళ్ళొచ్చా? పాసిబులే కాదుగా. సేమ్ స్పీడ్ లో వెళ్ళడం పాసిబులే కాదు. అప్పుడు బ్రేక్ పెడతాము, స్టాప్ చేస్తాము సిగ్నల్లో, అలా ఆపేసి ఆపేసి వెళ్తాము. అప్పుడు ఏమవుతుంది? స్పీడ్ ఇంక్రీజ్ చేస్తాము, డిక్రీజ్ చేస్తాము. అది యూనిఫామ్ మోషన్ కాదు. అది యూనిఫామ్ మోషన్ కాదు. కానీ ఒకటే స్పీడ్ లో వెళ్తున్నప్పుడు, కరెక్ట్ గా బాగుండు రోడ్ లో వెళ్తున్నప్పుడు ఏమవుతుంది? సేమ్ స్పీడ్ లో వెళ్తాముగా, అది యూనిఫామ్ మోషన్. అందరికీ అర్థమైందా ఇప్పుడు? నార్మల్ గా యూనిఫామ్ మోషన్, యాక్సిలరేటెడ్ మోషన్ కి డిఫరెన్స్ అర్థమైందా మీకు? ఎస్ ఎస్ సార్, థ్యాంక్ యూ సార్. ఎక్స్ట్రా
Thanks.
ఎస్ సార్, కంటిన్యూ చేద్దాం.
Okay, thanks. Okay, great. Thank you. So today we focus on uniformly accelerated motion. Okay, today we focus on uniformly accelerated motion. So uniformly accelerated motion refers to motion where an object velocity changes at a constant time. So that means acceleration is constant. So this is known as uniformly accelerated motion. Acceleration is constant. Okay. So velocity, already you know that in terms of speed, velocity is a scalar vector quantity. It has value and direction. So it changes at a constant rate or constant time. So for 1 second, one object velocity is 2 meter per second, and another for the another 1 second, again 2 meter for 5 seconds. So this like that, velocity changes at a constant rate, constant time, meaning acceleration is constant. Okay, so a classic example for this uniform accelerated motion is a freely falling object. Freely falling objects. You know that freely falling object where gravity provides a constant acceleration. If you throw one ball or one stone in upwards, it will come to the ground. Why? Why? It is due to the gravity. So that gravity provides a constant acceleration. Already you know that 9.8 meter per second square. What is that? Why 9.8 meter per second? What is that? Why we can like that we can say 10.1 today for tomorrow 11.2 meter per second square. Why we cannot we should not tell like that? Why we tell that gravity only 9.8 meter per second? It is a constant value. So constant value means constant acceleration. That gravity provides an this acceleration to the all the body. Yes, is it correct? Okay. Okay. So uniformly accelerated motion means where acceleration is constant. Please underline that word acceleration is constant. We will derive three equations to help us solve many real life motion problems. The three kinematic equations we will learn are the tools to analyze this motion. They connect five quantities. That three kinematic equation connect the five quantities. That is first one, initial velocity. So V naught. Okay. Second one, final velocity. Just to put V. Okay. For the initial value, put the 0 in the subscript. Okay. So for the final velocity, just to put V. Acceleration. A. Time. So fourth one, time. T. And final displacement. So X. Okay. So that kinematic equation, which is very helpful to us because we can analyze this type of motion like uniformly accelerated motion. That kinematic equations connect that five important terms or quantities, that is here initial velocity, final velocity, acceleration, time, and displacement. Okay. Now I will show one simulation just to look at that. Wait. Sorry. Just look at that here. Okay. So first graph. So you can see that there are three graphs. First graph, X and T. So this is position time graph. Okay. X means already you know that displacement, sir, distance, sir. So object position. So which is along the Y axis and time in the X axis. We can put time always in the X axis because time is a independent quantity. Okay, time does not wait for someone or something. Okay, that's why we can put time always in the x-axis. Okay, so first one graph, time and position. So this is a position time graph. You can see that unit in meter. Second graph denotes that, represent that V and T. So velocity time graph. V means velocity. So unit meter per second. And third one is, already you know that, A and unit meter per second square. So A means acceleration. So acceleration time graph. Now, just look at that first graph, that is position time graph. Okay. So I will put one value. So 2. Just look at that. What did you notice? In position time graph, one straight line is there. Straight lines means constant. Yeah. So you put that 2 meter per second. So that means in every second, that object travels 2 meter. Is it correct? In every second, object travels 2 meter. That's why in that position time graph, there is a straight line. Okay, now just look at that first graph only. What did you notice that, sir? In acceleration box, you have put 2 or 3 some value in that. So acceleration means change in velocity. Change in velocity means the object speed or velocity changes over time. Is it correct? Yes, good. So object velocity changes means that displacement per time changes, because velocity, already you know that velocity is equal to displacement by time. So that's why in the position time graph, there is a parabolic line. So this looks like a parabolic line, parabolic path. So this parabolic curve represent the change. In previous graph, you saw that straight line. Straight line means constant, but here just look at that first one graph only. Okay. So in this case, there is a parabolic curve in that first graph. So velocity changes, displacement changes. Okay. Displacement changes over time. Okay. Now, so now we can recall that acceleration. Acceleration means changing velocity by time. Yeah, is it correct? Already I told you that change in velocity means final velocity minus initial velocity. So final means V, initial means V naught by time. So A is equal to V minus V naught by T. Is it correct? For constant acceleration, so constant acceleration means velocity, sorry, acceleration does not change. Yes. So the final velocity V gives V naught plus A into T. So this is for constant acceleration. In that graph, position time graph, you have seen that velocity changes, uh, acceleration changes. For uniformly accelerated motion, the velocity time graph is a straight line. That is, velocity changes linearly. So acceleration means change in velocity by time. Change in velocity means final velocity by minus initial velocity by time. For constant acceleration, final velocity v equal to v naught plus at. Okay, this is clear? Okay, now ma'am will tell you.
Yes, sir.
Yes.
One second, I will also share my screen.
Okay.
ఓకే, ఇప్పుడు ఏం చూసాము? సార్ ఏమన్నారు? ఈ 5 క్వాంటిటీస్ రిలేట్ చేస్తున్నలాగా ఒక ఈక్వేషన్ చెప్పారు కదా సారు. ఏ క్వాంటిటీస్? ఫస్ట్ ఇనిషియల్ వెలాసిటీ, నెక్స్ట్ ఫైనల్ వెలాసిటీ, యాక్సిలరేషన్, టైం అండ్ డిస్ప్లేస్మెంట్. ఈ 5 క్వాంటిటీస్ రిలేట్ చేసి సార్ ఒక ఈక్వేషన్ చెప్పారు. ఆ ఈక్వేషన్ ఎలా ఉంది? దానికి ముందు ఫస్ట్ దీన్ని చూడండి. ఈ వీడియోలో న్యూటన్ చదువుతున్నప్పుడు నిద్రపోయేప్పుడు తల మీద ఒక ఆపిల్ కింద పట్టింది. అప్పుడు ఆపిల్ చూసి ఈక్వేషన్స్ అన్ని చెప్తున్నారు. మనము ఆపిల్ చూస్తే ఏమంటాము? తినడానికి అనిపిస్తుంది కదా. ఇలాంటి ఈక్వేషన్ ఏం రాదు కదా, కానీ అలా ట్రై చేయొచ్చు. ఇప్పుడు ఇలాంటి ఒక బాల్ పోతున్నప్పుడు యాక్సిలరేషన్ యూనిఫామ్ గా ఉంటే సార్ ఒక ఈక్వేషన్ చెప్పారు కదా. ఏ ఈక్వేషన్ చెప్పారు? ఎవరైనా అన్మ్యూట్ చేసి చెప్పండి. ఫస్ట్ ఈక్వేషన్, ఫస్ట్ కైనమాటిక్ ఈక్వేషన్ సార్ చెప్పారు కదా. ఇక్కడ కింద ఉంది, ఎవరికి కనిపిస్తుంది? ఎస్, v is equal to v naught plus at. v is equal to v naught plus at అనేది ఫస్ట్ ఈక్వేషన్ ఆఫ్ మోషన్. అర్థమైందా అందరికి? ఎస్ సార్, ఐ థింక్ అందరికి అర్థమైంది. ఐ థింక్ దే వాంట్ టు లెర్న్ అబౌట్ ద సెకండ్ వన్ ఆల్సో. ప్లీజ్ టీచ్ దెమ్ సార్.
Okay, welcome. Thanks. Okay. So this is a first kinematic equation. So, okay, right. Now, in your book, you have seen one graph like that. So, already told you here time, here velocity. This is origin O. So, uniformly accelerated motion means objects, sorry, one second. Uniformly accelerated motion means object at times equal to 0, it has some initial speed or initial velocity. So that's why in your book there is a v naught here. So v naught means initial velocity. Okay. So constant velocity means there is a line straight well like that. This is a constant acceleration. This means velocity does not change over time. That is called as constant velocity. In uniformly accelerated motion, velocity changes over time. Already told you. So object from its initial speed goes like this. Okay, goes like this. So we can connect by dotted line like this. So this is T and okay. So object has some initial speed and after some time, it takes some time and travels like this because of for uniformly accelerated motion, velocity changes and object reach this position B. Okay. So the area under this curve, it includes two type of shape. One is triangle, another one is rectangle. Okay. So area between 0 and T, which includes area of triangle plus area of rectangle. Area of rectangle. Okay. Is it clear? Okay. Already you know that the formula for area of triangle. What is the formula of area of triangle? If you know the answer, please tell me. What is the formula for area of triangle? Okay, good. Okay. So area of triangle of big H. So B means width or breadth. H means height. This is a formula for area of triangle. Okay. And what is the formula for area of rectangle? So this is the area of this rectangle. What is the formula to find that area? Yes, correct. That is BH. As usual, B means breadth, H means height. Okay. So this is breadth, B. This is height. Okay. For rectangle, this is a height. For a triangle, this is a height. Object from 0 to V. So that is a height. Is it correct? So height means V. But from this position to this position, there is a height means B minus V naught. So B minus V naught. This is a height for that triangle only. So from this to from this. This is the height of that triangle. Then what is that height of the rectangle? What is the height of the rectangle? If you know the answer, please unmute yourself and tell that answer. So you already know that the height and breadth of that both triangle and rectangle. So breadth common to both shape triangle rectangle. That is B. But so B, which denotes that the distance between the 0 and T. And height for triangle, I told you from this to from minus this position. So this is the height. What is the height of that rectangle? Yes, V naught. Because V naught here. So there is a distance between from this position to this position. So V naught means height of that rectangle. V minus V naught means height of that triangle. Is it clear? Okay. So now we have to find total displacement of that object. So we have to add area of the triangle plus area of the rectangle. So like that, total displacement, because that object start from 0 and it has some velocity v naught and it goes like that and reach that B. So object travels by that two uh, shape, triangle, rectangle. Okay. So total displacement means we have to add area of triangle plus area of rectangle. Already I told you area of triangle means R, big H, and area of rectangle means big H. Breadth. What is the value of breadth here? What is the value of breadth here? You can tell me. T. Is it correct? Okay. And what is that height? So t into height for a triangle b minus b naught plus what is the breadth of the rectangle? As usual, t. Height means b naught. So we can rearrange these equations. For simplicity, we can write like this: v minus v naught into t and plus v naught into t. So here total displacement. Okay. So total displacement denoted as x. Already in our physics book, we use the term x, s, h, but like that. Okay. X means displacement, distance. S means also denotes that distance displacement. Okay. So x is equal to half v minus v naught into t plus v naught into t. Okay. Already we know that from previous equation. So from that is previous equation, v is equal to v naught plus at. This is a first kinematic equation. Okay. We can move v naught from this position to this position. So v minus v naught equal to at. Is it correct? Just take that v naught from that position to that position. So that sign will change. So that's why v minus v naught is equal to at. Okay. Now look at that. V minus v naught. So we can put for v minus v naught at here. Okay. So now I will rewrite that equations. X is equal to half. We can replace v minus v naught by at. So at already t is there. Yes. And plus v naught t. At t into t square. So half at square plus v naught t. This is as well as displacement. Okay. So now we can rearrange this equation also. So v naught plus t plus half at square. So this is the third kinematic equations. Sorry, second kinematic equations. Yeah, already we familiar with that first kinematic equation. Now we derive that second kinematic equation, which is x is equal to v naught t plus half at square means displacement. We have to find displacement in this type of motion, in this type of case, kinematic equation or uniform absolute motion. We have to find like this: v naught into t plus half at square. If we have the values of velocity, time, acceleration, we can put here and then we can find the displacement. So this is a second kinematic equations. Okay. Now we will move into the next kinematic equation. That is the third kinematic equation and the final kinematic equations. Okay. Right. So now,
Sir, shall I show a quick recap to the students?
sure, madam. Sure. Okay.
Sure. Let us just see a quick recap. ఇప్పుడు ఏం చూసాము? ఫస్ట్ ఈక్వేషన్ ఆఫ్ మోషన్ చూసాము. తర్వాత సెకండ్ ఈక్వేషన్ ఆఫ్ మోషన్. సెకండ్ ఈక్వేషన్ ఆఫ్ మోషన్ చదివిన తర్వాత ఫస్ట్ ఈక్వేషన్ గుర్తుందా లేదా? ఇక్కడ చూడండి, టైము, ఇనీషియల్ వెలాసిటీ, యాక్సిలరేషన్, కరెంట్ వెలాసిటీ 4 వాల్యూస్ ఉంటాయి ఆ ఈక్వేషన్ లో. దాంట్లో కాన్స్టెంట్ వాల్యూస్ ఏది? ఇనీషియల్ వెలాసిటీ మారదు, ఎందుకంటే ఇనీషియల్ ఏ వెలాసిటీలో ఉందో అది మారదు. తర్వాత యాక్సిలరేషన్ మారదు, ఎందుకంటే కాన్స్టెంట్ యాక్సిలరేషన్ లో చూస్తున్నాము. కరెక్టా కాదా? ఇప్పుడు నేను స్టార్ట్ చేస్తే ఏం మారుతుంది? టైము, వెలాసిటీ మాత్రమే. కరెక్టా? ఇప్పుడు ఇంక్రీజ్ చేస్తున్నాను, ఇప్పుడు స్టాప్ చేశాను. టైం ఉంది, ఇనీషియల్ వెలాసిటీ ఉంది, యాక్సిలరేషన్ ఉంది, కరెంట్ వెలాసిటీ ఉంది. ఏ ఫార్ములా యూజ్ చేయాలి? ఫస్ట్ ఈక్వేషన్ ఆఫ్ మోషన్, v ఈజ్ ఈక్వల్ టు v నాట్ ప్లస్ ఏటీ ఫార్ములా యూజ్ చేయాలి. దానిలో సబ్స్టిట్యూట్ చేస్తే ఏంటిది? ఈ ఫార్ములాలో సబ్స్టిట్యూట్ చేస్తారు కదా, సబ్స్టిట్యూట్ చేస్తే v ఈజ్ ఈక్వల్ టు 10.4 అని ఉంది, ఇక్కడ పెట్టారు దాన్ని. అర్థమైందా? ఇప్పుడు స్టార్ట్ చేస్తే మళ్ళీ చూడండి, ఇనీషియల్ వెలాసిటీ యాక్సిలరేషన్ మారదు, టైము కరెంట్ వెలాసిటీ మాత్రమే మారుతుంది. మళ్ళీ ఇప్పుడు స్టాప్ చేస్తే ఈ మూడు వాల్యూస్ ఉన్నాయి కదా, ఇది యాక్సిలరేషన్. మూడుని ఇక్కడ ఈక్వేషన్ లో సబ్స్టిట్యూట్ చేస్తే కరెంట్ ఏ వెలాసిటీలో ఉందని వీ కెన్ ఫైండ్ అవుట్. అర్థమైందా? ఇప్పుడు నెక్స్ట్ ఏం చూసాము? సెకండ్ ఈక్వేషన్ ఆఫ్ మోషన్. వాట్ ఈస్ ద ఫార్ములా? ఎస్ అంటే ఎక్స్ అని తీసుకున్నారు సార్, కరెక్టా? అంటే వాట్ ఈస్ ఎక్స్? Distance or displacement? Yes, very good. Displacement we will take as x, which is equal to v naught t plus half a t square. So ఇప్పుడు రెండు ఈక్వేషన్ గుర్తుంది కదా, ఇప్పుడు థర్డ్ ఈక్వేషన్ కి వెళ్దామా? ఓకే సార్, ప్లీజ్ టీచ్ దెమ్ ద థర్డ్ ఈక్వేషన్.
Text. Okay, now we will move into that third equation of motion. So before that, we can write the previous equations. X is equal to 1 by 2 v minus v naught into t plus v naught into t. Is it correct? Okay. You can see that v minus v naught by 2 like that. Is it correct? V minus v naught by 2. So in this case, we can put average. Okay, put average like that. For example, just you can write like this. Okay, you can write like this, and then you can multiply t. Is it correct? Okay. So suppose if you want to add this term to this term, we have to take LCM. So that's why we can put like this. 2 V naught by T by 2. Is it correct? So Vt by 2 minus V naught by T by 2 plus V naught by V naught into T. So we can take the LCM. So cross the two multiple that term. So like this. So Vt minus V naught T, that then only we can add those terms. Okay. So V naught T plus 2 V naught T by 2. Okay. Now you can look at that these two terms, the same term V naught T. So here one is there. If nothing placed here, that means one is there. Yeah. 1 V naught T plus 2 V naught T. We can add this V naught T minus V naught T plus 2 V naught T. We will get plus V naught, because minus 1 plus 2 gives plus 1. That's why I am putting V naught T. So now putting 2 here. Okay. So now take the T term common as a common. So V plus V naught by 2 into T. You know that V plus V naught by 2 gives average. For in your school, in your class, there are 5 students, or it may be 20 students. Okay. To find the average, what you have to done like that? You have to add all student mark with number of divided by the number of students. Yes. So there are two velocities there. So V plus V naught by 2, which gives average velocity. So V plus V naught by 2 replaced by V bar. So there is a line in V. So that line is called as average or bar. So V bar means average velocity in this case. So we can write x is equal to average velocity into time. Already you know that displacement. Okay, displacement gives displacement means velocity into time, because velocity equal to displacement by time. So that time goes here. So displacement equal to velocity into time. So that's why we can put x is equal to v bar into t. Okay. V bar gives v plus v naught by 2, which is a constant acceleration only. In your book, you can see that constant acceleration. Okay. So now for t time. Already in the from the first kinematic equation, v is equal to v naught plus at. You can replace, you can rearrange this equation like this. Yeah. And then this a goes here. So v minus v naught by a, which gives time. Okay. So substitute this time and average velocity in the equation of, so like this, v bar into t, v minus v naught by a. Already you know that average velocity v bar means v plus v naught by 2. And now this equation. And now we can put that value of time like this. You can multiple those times. This is a, this is 2. Okay. So we can get 2a. But here you can see a plus b into a minus b. Yeah, a, this is like, you can take as a and this is taken as b. So this is taken as a, this is taken as b. A plus b into a minus b. What will come? A square minus b square. So a square minus b square. Is it correct? So this is a displacement. X is equal to b square minus v naught square by 2a. Okay. Now you can take that 2a into here. So 2a into x, 2ax, 2ax. So which gives v square minus v naught square. Is it correct? Okay. Now we will write that equation here. So sorry. So previous equation 2 into ax equal to v square minus v naught square. So v square minus v naught square is equal to 2ax. We can take that v naught square from this position to this position. So the sign will change, v naught square plus 2ax. This is a third kinematic equations. Okay. This is the third kinematic equations. Okay. So this equation connecting that 5 quantities, already you know that v naught, v, a, t and x. So these are the kinematic equation for rectilinear motion. Rectilinear motion means straight line motion. Okay. Okay. Now ma'am will tell you about the third equation. Yes, ma'am.
థ్యాంక్ యూ సార్.
Thanks.
నేను ఫస్ట్ ఏమి స్టార్ట్ చేయడానికి ముందు న్యూటన్ ది ఫోటో చూస్తారా అందరం? న్యూటన్ గురించి మాట్లాడాము కదా, న్యూటన్ అంటే ఎవరని ఫస్ట్ చూడాలి కదా. ఇక్కడ చూడండి, దిస్ ఇస్ న్యూటన్. ఎస్, ఈ న్యూటనే ఏం చేశారు, చెట్టు కింద చదువుతున్నప్పుడు యాపిల్ కింద పెట్టి ఈ ఈక్వేషన్స్ అన్ని ప్రపోజ్ చేశారు. అండర్స్టూడ్? దిస్ ఇస్ న్యూటన్. సో నెక్స్ట్ టైం ఆయన ఫేస్ చూస్తున్నప్పుడు మీకు గుర్తుపెట్టుకోవాలి ఇది న్యూటన్ అని. ఇప్పుడు జస్ట్ ఒక రీక్యాప్ చేస్తాను. కైనమాటిక్ ఈక్వేషన్స్ ఏంటి? ఫస్ట్ ఈక్వేషన్ v is equal to v naught plus at. తర్వాత s is equal to v naught t plus half at square. ఇది సెకండ్ ఈక్వేషన్. థర్డ్ ఈక్వేషన్ v square is equal to v naught square plus 2as. ఇవి మూడు ఈక్వేషన్స్ ఎందుకు కావాలి? సపోజ్ మనకి వెలాసిటీ కావాలంటే ఇనీషియల్ వెలాసిటీ తెలిస్తే, యాక్సిలరేషన్ తెలిస్తే, డిస్ప్లేస్మెంట్ తెలిస్తే వెలాసిటీ తెలియొచ్చు. నెక్స్ట్ డిస్టెన్స్ కావాలంటే ఇవి అన్నీ తెలిస్తే కనపడొచ్చు. అర్థమైందా అందరికి? చాలా ఈజీ కదా, మూడే ఈక్వేషన్స్. సార్ గ్రాఫ్ అన్ని చూపించారు కదా. ఎస్, గ్రాఫ్ నుంచి ఎలా కనపడాలి అని కూడా చూపించారు సార్. ఎవరికైనా ఏదైనా డౌట్ ఉంటే ఇప్పుడు అన్మ్యూట్ చేసి అడగండి. ఎస్, నేను ఆల్రెడీ చూపించాను మీకు. టైం మారుతుంది, తర్వాత వెలాసిటీ మారుతుంది, కానీ ఇనీషియల్ వెలాసిటీ మారదు, యాక్సిలరేషన్ మారదు, ఎందుకంటే అది కాన్స్టెంట్ వాల్యూస్. అర్థమైంది కదా? డౌట్ ఉంటే ప్లీజ్ అన్మ్యూట్ చేసి అడగండి. ఎస్, ఎవరికైనా ఏదైనా డౌట్ ఉందా? అందరికీ ఎలా అర్థమైందా? ఓకే. ఎస్ సార్, ప్లీజ్ ప్రొసీడ్ సార్. I think everyone has understood.
Okay, thanks. Okay, now we will look at to another one case for your imagination, for your reference. So now look at that into second graph. Okay, so now I will put like any one value 3. Just look at that graph. Start. What did you notice? Take notes. Okay, you can tell your answer via chat box, or you can unmute yourself in the mic. Okay, what did you see? So 3 initial speed 3 means object travels already. Okay, object already in that some position, and it travels with a 3 meter per second. For every second that object travels 3 meter. That's why that's only that called is a constant velocity. Okay, okay, so that's why in that second graph, that is velocity in the time graph, there is a straight line, because so you can see that the straight line under that 5, so it denotes the 3. Okay, because I putting that put that 3 meter per second, that's why that line comes from 3. Okay, so the object travels constant velocity, constant distance in equal interval of time. That's why in first graph, now look at the first graph. In position time graph, there is a straight line, so which denotes a constant displacement. Okay, okay. Now you can see, one second. Now you can see that I am putting 3 in the acceleration box. Now just look at the graphs. Now look at the second and third graph. So I am putting 2 meter per second square. It's a acceleration value. That's why in the third graph, that is a acceleration time graph, there is a straight line from 2. So which is constant, which denotes a constant. Yes, is it correct? So that object or car travels with the acceleration, equal acceleration, that is constant acceleration. That is uniformly accelerated motion, constant acceleration. Okay. Now look at the second graph. In previous graph, you are like you have seen that straight line from that value 3. Now that object travels from 0 to and like this straight line, slope line. Okay. So so what did you understand from this graph, from compared to previous one? Previous one just a straight line from that, from one value. Now For that second graph, the object travels from the zero because from the origin, but it is a slope line. Slope line denotes that object travels with changing velocity. So changing velocity means equal amount of velocity changes in equal amount of time. That's why it denotes it called as a constant acceleration. So from this graph, you have seen that straight line, slope line means velocity linearly changes with time. Okay. So now you can look at that here. So V is equal to 15.13 meter per second. Just look at that. Please, just look at that. So it changes. For every second, object velocity changes. That's why there is a graph which is a sloping line. Okay. So linearly changes with time. So that straight line or sloping lines means linearly changing that quantity with the time. So here velocity, so velocity linearly changing with the time. It denotes as denoted by the graph is a sloping line. Okay, right. So now we will solve one problem related to this concept. One second, I will write one concept. Very simple problem. A ball falls freely for 2 seconds. Okay, this is a question. Find distance. Please work out that sum and tell me the answer. A ball falls freely for 2 seconds. So already I told you, freely falling object denotes that uniformly accelerated motion. Gravity provides a uniformly accelerated motion, uniform acceleration. So ball falls freely under that condition of uniform accelerated motion. Okay. A ball falls freely for 2 seconds. For 2 seconds, ball falls freely. What is the distance? What is the distance? How to find the distance? You can recall your three kinematic equations. You can take any one of the equations which is very related to that this this problem. You can take the first kinematic equation or you can take the second kinematic equation, whatever else, but you have to find distance. How to find that distance? If anyone have answer, please unmute yourself and answer. Tell the answer. So, which is very useful for other students also. Very, very simple problem. Okay. So, for the time being, I will tell that step by step. Okay. There are only two steps. Okay. Right. A ball falls freely for 2 seconds. So, 2 seconds means time. The ball falls freely. So, under the gravity. So, Earth gives a or Earth provides a acceleration. So, A. So, already I told you acceleration constant. So, 9.8 meter per second square is a constant acceleration. Time is equal to 2 seconds. Distance means which may be denoted as x or yes. Okay. From our book, x denotes as a distance. Okay. X is equal to x is equal to what is the formula for x? What is the formula for x? Just tell me what is the formula for x? Yes, x is equal to v naught t plus of at square, which is the formula for displacement. Yes, we can put v naught. This is the initial velocity. Okay, A ball falls freely means it don't that object don't have a initial velocity. Okay, so we can put 0 here, 0. So 0 to anything, 0. Now we can put only here a 9.8 t 2 seconds. So 2 into 2, 4. So 2 square, 2 square means 4. Okay, we can cancel that 2, 4, 2. So 9.8 into 2, 19.6 meter. So this is a value of the sum. So this is a distance of the for this sum. Okay, a ball freely for 2 seconds, it travels a distance 19.6 meter. Okay, okay. So let's recap our today class. So uniformly accelerated motion means constant acceleration. You have familiar with the three kinematic equation. S is equal to V is equal to V naught plus AT, and X is equal to V naught T plus half AT square, and finally V square is equal to V naught square plus 2AX. This is today class. Okay. If anyone have any doubt, please ask me, madam. Now
ఎస్ సార్, ఎవరికైనా ఏదైనా డౌట్ ఉందా? ప్లీజ్ అడగండి, అన్మ్యూట్ చేసి అడగండి.
one student told the answer, madam. Very good.
వెరీ నైస్. ఇక్కడ చూడండి, నేను ఆల్రెడీ స్టార్టింగ్ లో చెప్పాను కదా, ఇక్కడ విజయవాడ నుంచి నెల్లూరుకి వెళ్తున్నామని అనుకోండి. అప్పుడు ఏమవుతుంది? సపోజ్ ఎప్పుడు వస్తాను, మీకు కాల్ చేస్తారు కదా, ఎప్పుడు ఇంటికి వస్తావు, ఎప్పుడు వెళ్తావు అని అడుగుతారు కదా. అప్పుడు ఇక్కడ చూడండి, ఇక్కడ ఏముంది? వి ఈజ్ ఈక్వల్ టు వి నాట్ ప్లస్ ఏటీ. వి తెలిస్తే, వి నాట్ తెలిస్తే, యాక్సిలరేషన్ తెలిస్తే ఎప్పుడు వెళ్తారని కూడా తెలియచ్చు కదా. సపోజ్ కాల్ చేసి అడిగితే ఇలా యూ కెన్ టెల్ హౌ యు ఆర్ టెల్లింగ్. ఓకే, నేను 6 గంటల్లో వస్తాను ఇంటికి, 7 గంటల్లో వస్తాను ఇంటికి. ఎలా చెప్తున్నారు మీరు? ఊరికే చెప్పకూడదు కదా, ఇలాంటి మ్యాథమెటికల్ క్యాల్కులేషన్స్ ఉన్నాయి. అర్థమైందా? ఈ రోజు చేసిన క్లాసు ప్రతిరోజు మనము యూజ్ చేస్తున్నాము. ట్రైన్ టైమింగ్స్ అని ఎలా క్యాల్కులేట్ చేస్తున్నారు? విజయవాడ నుంచి నెల్లూరుకి రావడానికి ఎంత టైం పడుతుందని ఎలా చెప్తున్నారు? ఇలాంటి క్యాల్కులేషన్ చేస్తున్నారు. ఎవరు చేస్తున్నారు? ఈ రోజు కంప్యూటర్ చేస్తుంది, కానీ మీకు తెలియాలి కదా ఎలా చేస్తున్నారని. అర్థమైందా అందరికి? డౌట్స్ ఉంటే ప్లీజ్ అడగండి, లేదంటే లెట్స్ మీట్ నెక్స్ట్ క్లాస్. ఒకసారి రివైజ్ చేయండి. మీ టెక్స్ట్ బుక్ లో ఇలాంటి క్వశ్చన్స్ ఉంటాయి, ట్రై చేసి చూడండి. డౌట్స్ ఉంటే నోట్ డౌన్ చేసుకొని నెక్స్ట్ క్లాస్ కూడా వచ్చి సార్ ని అడగొచ్చు. సార్ విల్ ఎక్స్ప్లెయిన్ టు యూ అగైన్ నెక్స్ట్ క్లాస్ ఇఫ్ యూ ఆర్ హ్యావింగ్ ఎనీ డౌట్స్. ఎస్, థ్యాంక్ యూ సో మచ్ ఫర్ ఎవ్రీవన్ హూ అటెండెడ్. ఎస్పెషలీ టీచర్స్ అందరికీ పెద్ద 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 థ్యాంక్స్. స్టూడెంట్స్ అందరూ కూర్చొని క్లాస్ వింటున్నారంటే మీరే దానికి రీజన్. థ్యాంక్ యూ సో మచ్ టు ఆల్ ద టీచర్స్ హూ హ్యావ్ హెల్ప్డ్ టు మేక్ షూర్ దట్ ద స్టూడెంట్స్ ఆర్ దేర్. అండ్ స్టూడెంట్స్ కి కూడా పెద్ద పెద్ద థ్యాంక్స్. స్కూల్ తర్వాత వచ్చి కూర్చున్నారు. థ్యాంక్ యూ సో మచ్.